Hello, Algebra 1. Today we're going to talk about adding and subtracting rational numbers. Before we can begin in that, we're going to compare some so we remember how to do that. Because, hey, who doesn't like comparing? Comparison? I can talk real good. So we notice that I have fractions. Oh no, fractions! Scary! Ah! We can do it. Excuse me. What we're going to do first is we're going to try and get a common denominator to compare about them. Reason being is, let's talk about these two writing utensils. I have a pen and I have a pencil. When I talk about both of them together, I can't say I have two pens. I can't say I have two pencils. I have to physically change the way I describe them. I use the word writing utensils because that's what they are. They're some kind of a writing implement. They're both kind of similar. They both get me to the same idea. They both write whatever it is I'm trying to write down. However, in order to talk about both of them together, I must physically change the way I describe them. That is the same with my fractions. I can't just say, oh, well, the 6 is bigger, so bam, 6 is bigger. Nope, not how that works. I have to physically change the way I describe them. They're going to still be equal. I mean, I can say a pen or a writing utensil. It's still something to write with. I'm not drastically changing or saying that it's not, I'm not magically turning this pen into a piece of yarn. Not saying, hey, I've got 2 pieces of yarn here. They are staying equivalent. That's the big key. Most people get scared with fractions because they don't know how to make them equal. I'm not sure why. But that's where we get scared, and I don't know why. So, pounding that into our brains, we're keeping things equal. Same. 2 writing utensils, 1 pen, 1 pencil. Okay. So in order to do that, we're going to try and find a common denominator. So I have the numbers 3 and 6. I know that I can multiply 3 into 6, so I'm going to keep that second one the same. And I'm going to try and turn that first one into something with a 6. So 3 times something gives me 6, and that something is 2. So I'm going to change this top by also a multiplication of 2. So 2 times 2 is 4. I'm going to compare these two numbers. Okay, now they have the same denominator. Ooh, big word. They have the same bottom. So compare the tops. Which number is physically larger? This one is larger. The 5 is bigger than 4. So when I go back to my answer, I have to go back to the original and then say that he is bigger. Okay, I am going to have you try this one on your own. Same general idea. Try it, see what you come up with. Pause video, work it through, come back, compare answers. If there's no work written on it and you just have the answers, it's going to have a really hard time doing your homework, guys. All right. I hope that's kind of what you got. We'll go from there and figure it out if not. Adding or subtracting like fractions. So what we're going to look for first is whether or not they have the same denominator. If yes, add or subtract the top. No. Change the problem. And what do I mean by change? Okay, let's go back to my writing implements. Pen, pencil. 2 writing utensils. Had to change my words, so we're going to change the problem. Pen, oops, pen. Ooh, it's been a really long day. pen, pencil, writing utensils. First problem. Let's take a look. Same denominator? Yes. Okay, so then it tells me to add or subtract the tops. So I have adding, so I'm going to add. There's no point subtracting if I don't have a subtraction sign. So 3 plus 1 gives me 4, so my answer is 4 over 5. I like kind of keeping that over my head. Too bad I can't keep it that way when I move my slide. Next one. Okay, same number. So I go ahead and add or subtract. In this case, I'm subtracting. So 7 minus 1 is 6 over 16. And I already know I'm going to have someone saying, well, hey, that can reduce. If it can reduce, reduce it. So what can go into both? That's right, 2. So divide both by 2. So I get 3 over 8. Don't worry, it's coming back. I notice that I have the same denominator. So I go ahead and subtract in this case. So I have 4 minus 7, so negative 3 over 9. And yes, I reduce, so I'm going to divide both by 3. So negative 1 over 3. And I like my handy dandy saying. So I'm going to go back to this, and I want to copy it. And he's going to come with me to our next page. Oh, stop being difficult. Hide away. Move this over a little bit. And put this over my face. Or on top of my face. Either way. Step number 1, do they have the same denominator? No, so we're going to have to change the problem. So I need to find a number they both have in common. So 2 and 3 can both multiply to 6. So I'm going to start by writing the new denominators, which we said was 6. And then I'm going to ask myself, well, how did that change? So 2 times 3 got me to 6. So I multiply by 3 over 3. So 3 times 1 gives me 3. And I'm actually going to go and we'll keep it like this. The idea was to change my colors, but it didn't really work. I wasn't paying attention. My bad. So 3 times 2 gave me 6. I'm going to multiply this by 2. So 2 times 2 is 4. And then now I can go back to what I was doing with adding. So I'm going to have a final answer over 6. So 3 plus 4 gives me 7. And you're like, whoa, 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 that's improper. You're correct. So I have 1 and 1/6. And I can move this guy over too. Pull him down a little bit. And I asked myself, hey, same denominator. Ooh, I didn't want yellow. Undo that. I want purple. Yellow is difficult to see. Do they have the same denominator? No. So I got to change the problem. So they both can go to 24. Yep. So 8 times 3 was 24. So 3 times 3 is 9. 3 times 8 was 24. So 1 times 8. Oops. I just realized that that's an equal sign, and that's not what that needs to be. That needs to be a subtraction sign. And this guy's way too far over, so I'm going to move him back. That's some of the cool parts of the smartboard is I can just move things after I've already written it. But there's a bunch of other stuff that's not fun to deal with. Oh, I don't want black. Let's go back to my purple color. And then 9 minus 8 is just 1, and that cannot reduce any farther. So 1 over 24. I want you to try this one on your own and see what you get as your final answer. Remember, pause video, come back, try it. If there's no work, then that means you don't know what you're doing. That's why I want to see if you know what you're doing. So make sure you're asking me these difficult questions, or else I can't help you. And I apparently decided not to do it. Did I? Anyways, -7 over 20. All right, adding decimals. So what you're going to do is you're going to take the numbers and line them up by the decimal points. And then you're just going to subtract them. So 5 minus 5 gives me that 0. 2 minus 3 is a -1. So my answer is -1. And if you don't believe me, let's get out of my old handy-dandy calculator. Oh, why is that coming? Keep pushing buttons when I try to do this. And you're probably like, but Miss Kimmy, Miss Kimmy, Miss Kimmy, Miss Kimmy, Miss Kimmy. That's not what the original problem says. Oh, watch this. I can move around my addition and subtraction as long as I keep the signs the same. If I have a plus negative, the negative will always win out. Always. So I always just do subtraction. Makes life easier. Okay. This is not the problem that I had next. I'm missing a problem. Did I not scroll down? Hey, found it. I didn't scroll down. Sorry. Since these are both negative to start with, what you're going to do is just add the numbers together. Remember, we line up by the decimal point. If there's missing stuff, we add zeros. So 2, 7, 11, 21. So you add them together, and then on the end, you just stick that negative sign on. Neato. Again, I have a plus negative. So my negative sign always wins. We are going to end up taking 7 over 16 minus 3 over 8. And we just did several of these problems, and I was trying to just fix my 8, because it doesn't look like the best 8 in the world. So I want you to pause the video and see if you get the same answer, since we did a bunch of these already. You should be a pro at subtracting fractions. And we should get 1 over 16. And I don't know if I have stuff below or if it's on the next slide. Subtracting decimals, again, I have negative, negative, and negative, negative. Oops, let me just switch this before I forget. So you might have heard the saying in English class, a double negative turns positive, so you didn't do that. I'm really bad at these because I try not to use them. Anyone ever played Never Have I Ever, and you decide to say never have I ever not done something? Yeah, that's a double negative, so it means you've done something. So it ends up turning into negative 32.25 plus 42.5. So I'm going to set it up for a subtraction problem because I can just rewrite everything. So I'm going to take my 42.50 minus 3225. And yes, I'm going to do the long way and borrow, and this turns into a 4, and this turns into a 10, and 10 minus 5 is 5. And then 4 minus 2 is 2. 2 minus 2 is 0. 4 minus 3 is 1. So I should get 1025. Woohoo, we're done. See you tomorrow.